Okay, see here, in LCR circuit, we discussed about, the impedance formula. The impedance formula is Z equal to under root of R square plus XC minus XL whole square. What is XC? XC is capacitive reactance, and which is equal to 1 by omega C, and XL is inductive reactance, which is equal to omega into L. Now, the formula here for impedance is under root of R square plus XC minus XL whole square. Now, at resonance frequency means what is the definition of resonance? It is a tendency to oscillate at a particular frequency called natural frequency. Means if the frequency of the inductor and the frequency of the capacitor, if both of them that means the reactance of the capacitor and the reactance of the inductor, when they both will become equal, then that condition is known as resonance phenomena or resonance condition. Now here XC equal to XL, then what will happen? Z equal to, when you substitute XC and XL both are equal, then it will become 0. So the answer is Z equal to under root of R square, which is equal to R. Now here we write XC is equal to XL, but what is XC? 1 by omega C. But instead of writing omega C, I am writing omega 0. Why omega 0? Omega 0 is known as resonance frequency. Omega 0 is known as resonance frequency. Okay. So here see, resonance frequency is omega 0. So what do we write here? 1 by omega 0 C equal to omega 0 into L. Now cross multiply, omega 0 square is equal to 1 by LC and omega 0 equal to 1 by root LC. Now what will happen? At resonance frequency, current amplitude is maximum. The current is maximum. So here, if you look at the voltage and current over there, here, see here voltage and current, if you see, the angle between both of them is phi, which is here omega t. Okay. Now what will happen? Voltage, this is the voltage and this is the current. So current and voltage, they are not in phase. There is a phase angle. How much is the phase angle? That is phi. That is how can we find out phi? So tan phi is equal to what? XC minus XL by R. I think we did before, no? Tan phi is equal to what? Tan phi is equal to XC minus XL by R, right? This is the formula. Is it not? Tan phi is equal to,
yes, sir,
XC minus XL by XC minus XL by R. Or we can also write tan phi is equal to what? Phi is equal to tan inverse of XC minus XL by R. This is the formula for what? This is the formula to find out the phase angle. See, we can write here voltage along x-axis also. That won't matter. The problem is when you draw along x-axis, it is not visible. The voltage line is not visible and current line is not visible if you write along y-axis. So that is the only reason we don't write along the axes. So here we write this is the voltage and this is the current. We don't know how much is the angle. We are not sure how much is the angle. So we are just writing phi. So the angle bit, this is omega t is what? This is initial phase and this is the phase angle. Now, if you draw the waveform, voltage will be same. Voltage will not change. Voltage is a sine wave. Voltage is a sine wave. And current is this is the current, okay, through the LCR circuit, which is I. Now, what he says here, if XC is greater than XL, means what? If the capacitive reactance is greater than the inductive reactance, then what happens? Phi is positive. Okay, the phase angle is positive and I leads, then current leads voltage. Phase angle is positive and current leads voltage. Such type of circuit is known as capacitive circuit. What happens in resistor circuit? Only resistor circuit. Is current and voltage they are in phase, they are out of phase, or what happens exactly? Can anyone say about this? In only resistors, pure resistor circuit. In pure resistor circuit, what will happen? Yes, can anyone say what happens in pure resistor circuit?
Sir, can you repeat the question?
The question is, if you are taking only pure resistor circuit, what happens here? If you take pure resistor circuit, if voltage and current, are they in phase or out of phase? Are they in phase or out of phase?
In phase.
They are in phase. Very good. What about capacitor circuit?
Out of phase.
Who is leading? No, it's not like out of phase, but who is leading here? And how much is the angle? Who is leading here? Current is leading voltage by how many degrees? 90 degrees. Current is leading voltage by 90 degrees in pure capacitor circuit. What happens in inductive circuit? What happens in inductive circuit? In inductive circuit, current is lagging voltage by 90 degrees. Current is lagging voltage by 90 degrees. Now, in capacitor, if XC is greater than XL, means what? Capacitive reactance is greater than the inductive reactance, then phase angle is positive and current leads voltage. That is, it is known as capacitive circuit. The second one is if XC is less than XL, phi is negative and current lags voltage by 90 degrees. Or that is said to be inductive circuit. The whole circuit will become an inductive circuit. Is that clear? And where do we use resonance phenomena? Resonance phenomena is used in tuning of radios and television sets. Okay, tuning of radio and television sets. Next, sharpness of the resonance. We will do that. Okay, can you please quickly copy this one? Then we'll go to the next concept, that is sharpness of resonance. Okay. Okay, sharpness of resonance. Okay. Now, in this case, well, what is that? See here, if you see the bandwidth, means as the frequency is increasing, what will happen? Frequency is measured in what? Radians per second. Frequency is measured in radians per second, which is on x-axis. Whereas current, which is measured in amperes, it is on y-axis. If you see this carefully, so this is the the characteristic, that is the frequency versus current characteristic. Okay, frequency versus current characteristic. Now in this one, so this is one way. The second one, we have one more like this, something like this. So this is, let it be 1 and let this be 2, whatever it is. See, what is this? This is set to be the bandwidth. Now this is the maximum. This value is set to be the maximum current. And this is the bandwidth. Okay, if this is omega 0, this is omega 0. So what will happen? This will be omega, this is omega 0 minus, that is omega 0 minus delta omega. One is omega 2 is greater than omega. So this is, let it be omega 1, let this be omega 2. Let this be omega 2. Now the difference, see once again, what is omega 0? Omega 0 is, and that is resonance frequency. Omega 0 is resonance frequency. Resonance frequency means the frequency at which the capacitive reactance and inductive reactance both will become equal, and the Z value will become equal to R, and the circuit is known as a resistive circuit. Is that clear? Once again, in resonance, at resonance frequency, the capacitive reactance and inductive reactance both will become equal, means XC will become equal to XL and Z equal to R. The whole circuit will become a resistive circuit. Okay, the whole circuit will become resistive circuit, and omega 0 is what? Angular frequency. Here omega 1 and omega 2 is there. So what we are writing here, omega 1 is equal to what? Omega 1 is equal to omega 0 plus delta omega. See here, I'll write that value also. Omega 2 is greater than omega 0. Omega 2 is less than omega 0. Oh, okay, sorry, I will take in the other way. This is omega 2 and this is omega 1. Better. So now omega 2 is less than omega 0, and omega 1 is greater than omega 0, means greater than the angular frequency. So omega 1 can be written as what? Omega 0 plus delta omega, and omega 2 can be written as omega 0 minus delta omega. What is delta omega? This value is said to be delta omega. This value is also known as delta omega. Okay, small delta omega. So this is the value. Now, what we are saying now, sharpness of, we want to explain what is sharpness of the resonance. To explain this, first we need to understand what is bandwidth. What is bandwidth? So omega 2 minus omega 1. Omega 2 minus omega 1 equal to what? 2 delta omega. 2 delta omega. That is said to be bandwidth of a circuit. That is said to be bandwidth of a circuit. Bandwidth of a circuit. That is said to be the, that is known as omega 2. So what is bandwidth of bandwidth for definition? Bandwidth is range of available frequencies. Okay. Bandwidth is range of available frequencies. Range of available frequencies is known as bandwidth. Okay. Range of available frequencies is known as bandwidth. See once again, here omega 2 is less than omega 0 and omega 1 is greater than omega 0. So omega 1 is equal to omega 0 plus delta omega. Omega 2 equal to omega 0 minus delta omega. Or we can write here omega 2 minus omega 1 is equal to 2 delta omega. Okay. So that is known as a bandwidth here. The bandwidth value is 2 delta omega. Okay. Now, so here we have what is omega 0 once again? Angular frequency is equal to what? 1 by under root of LC. Okay. 1 by under root of LC. This is the value. And I am equal to what? Vm by R. Okay. So if you want to find out the maximum current, one second.